Hi friends, this is Professor Prashant. Today we are going to start with 9th standard chapter 4, that is pressure in fluids and atmospheric pressure. Now I know that this is not the time to start with this chapter, but since this Webgear school has already finished 3 chapters, so I want to start one chapter which is common to all, that is I am starting with 4th chapter. Now, what is pressure? Now, before we start with pressure, there are two important terms. One is a force and second is a thrust. Now, what is a thrust? We can say first important term is a thrust. Now, thrust is a force acting normally. Force acting normally is called as what? Thrust. Now, thrust is a force which is acting normally. Say I will consider this surface on which I am applying force like this. This is the normal force. I am standing over here. My weight is acting normal to this surface. So therefore it is called as thrust. But if I push this board like this, making some angle, then it is not called as thrust. It is called as what? Force. Now over here, this is what is a normal force acting on this surface, that is called as what? Thrust. Now next term is what? Pressure. Now what is pressure? Pressure is the thrust per unit area. Thrust per unit area is called as pressure. That is force acting normally per unit area, surface area is called as what? Pressure. So pressure is denoted by letter P. This is nothing but, therefore it is thrust upon area. Now thrust is a kind of force upon area. Now what will be SI unit of pressure? So SI unit of pressure, force is in Newton, area will be in what? Meter square. So this is written as Newton per meter square, which is also called as what? Pascal. But अगर word में है तो PA, and if it is entire word, so it is Pascal. Right? This is name of the scientist, therefore P is small, that is Pascal. Now we'll go with distinguish between thrust and second will be what? Pressure. The first point of distinguish will be the definition of thrust and definition of pressure. Second point of distinguish is a SI unit of thrust is Newton. CGS unit is dyne. This is Newton, this is dyne. Over here it is Pascal, and this is what? Dyne per centimeter square. It is dyne per centimeter square. Third point of distinguish will be, this is the vector quantity. This is which quantity? Vector. But pressure is a scalar quantity. Now there are two types of physical quantities. The quantity which require only magnitude, they are called scalar quantities, and the physical quantity which require both magnitude and direction, they are called as what? Vectors. Now what do you mean by physical quantity? Physical quantities are all measurable quantities. First chapter you must have done. All measurable quantities are what? Physical quantities. They are divided into scalars and vectors. Scalars which require only magnitude, that can be completely expressed by its magnitude only, they are called scalar. And if they require both magnitude and direction, they are called as what? Vectors. So here thrust is a vector and pressure is a scalar quantity. Now this part is important. They can ask numerical based on this. Now the next part over here, how they are related, SI and CGS unit. This is your SI unit. What will be CGS? CGS will be what? Dyne per centimeter square. Right? Now how they are related? Newton and dyne. So for that you have relation. 1 Newton is 10 raised to 5 dyne. अब ये कहाँ से आया? So we have force is equal to what? Mass into acceleration. Now this is 1 Newton is equal to what? 1 kg into what? 1 meter per second square. Say 1 kg is written as what? 10 raised to 3 gram, and 1 meter is 10 raised to 2 centimeter per second square. So that comes out to be 10 raised to 5 gram centimeter second is to minus 2, which is 1 Newton is 10 raised to 5 dyne. This is one relation. Now over here, how they are related with dyne and centimeter square. Check. You have, say we write ulta, 1 Newton per meter square is equal to 1 Newton is how much? 10 raised to 5 dyne, right? 1 meter square is 10 raised to 4 centimeter square. ये कैसे आया देखो? 1 meter is 10 raised to 2 centimeter. So 1 meter square is 10 raised to 2 centimeter the whole square. So that comes out to be 10 raised to 4 centimeters. That is that relation. So if it go up, so this is 10 raised to 5. ऊपर जाएगा तो minus into 10 raised to minus 4. This is dyne per centimeter square. So this is 10 raised to 1 dyne per centimeter square. This is 1 Newton per meter square. This is the relation between SI unit of pressure and CGS unit of pressure. This is one part. Now we'll go with the next part. Now next part is what? So what are the questions based on this part? Define thrust, define pressure, distinguish between thrust and pressure. This is frequently asked question. Units, right? All that part. Then conversion. They can ask this part for fill in the blank. This is there in that third chapter, this relation. We'll do that chapter, at that time we'll discuss this part. Right now, we'll just proceed with the next part. Just check. Now, the next part is the pressure depends on what factors. There are two important terms. One is pressure and second is pressure due to liquid column. Over here, since pressure is equal to what? Force upon area, that is thrust upon area, more precise. So in normal words, we write pressure is equal to force upon area. So pressure is directly proportional to force. So if I increase the force, pressure will also increase. This is first part. Second part, pressure is inversely proportional to area. So if I increase area, pressure will decrease. If I increase area, pressure will decrease. Now what are the example for this? Example for this is very important. Now check first part. You take a brick. This is horizontally, I am placing this brick. Now if I place this brick horizontally, I'll just take this part. Say this is my brick. Right? This is my brick. If I place this brick horizontally, what will happen? Surface area is more. Surface area is what? More. So over here, if I increase the area, effect of pressure will decrease. Effect of pressure will decrease. But same brick, if I place vertical, the area in contact will be less. So effect of pressure will be what? More. Now when you take that pin which is used in check to attach some part, that is called pin. The tip of that pin is very sharp. So if the sharpness is more, that means area is less, effect of pressure will be what? More. More easily you can put that tip, you can press that pin. That is what is the pressure. Now if you increase the force over here, pressure will also increase. If you increase the force, pressure will also increase. And if you decrease area, pressure will increase. Now we'll go with the next part, that is expression for pressure due to liquid column. Pressure due to what? Liquid column. Now here you have, that is expression for pressure due to liquid column. Now just check this part properly. We'll consider this is the container, right? This is the open part. This is filled with liquid up to this level. Now this is called as free surface of liquid. This is free surface of liquid. What is free surface of liquid? The surface of liquid which is exposed to air is called free surface of liquid. Now we'll consider one point. So we'll consider one say cylinder over here. ठीक है, I will consider this cylinder of same height. Now this is called as liquid column. This is called as what? Liquid column. I will not consider this, but consider up to this one. So liquid column of say height h, right? This is from free surface. Now this is the liquid of density rho. This is the liquid of density rho. This sign is called rho, R-H-O, rho, right? Now what are the forces acting on this part over here? What is the weight? That force is nothing but weight. So what is pressure? Pressure is nothing but thrust upon what area? Over here thrust is nothing but the weight of liquid column. This is nothing but what? Weight of liquid column upon what area? But over here weight of liquid column is mg, area is what? A. Weight of liquid column is what? Mg, because weight is mass into acceleration due to gravity, which is mg. Say this is equation number 1. Any problem with this? Sure. Now we have, since density is what? Mass upon volume. Density is what? Mass upon volume. Mass will be m, volume is what? V. I will just write this, rearrange this mass as it is, volume as area into height of liquid column, because what is the volume of the cylinder? It is base area into what? Height. So A into H. So can I write here, therefore mass is equal to, this is rho, right? So mass is equal to rho AH. This is the equation number 2. Now what I will do, I will substitute equation 2, this value I will substitute over here at this place in equation 1. So if I substitute, that comes out to be P is equal to, instead of M, this is rho AH G upon A. A cancel. So I can write P is equal to what? H rho G. So this part is very important. Now what is P over here? It is pressure due to liquid column. So right here where P is what? Pressure due to liquid column. Pressure due to what? Liquid column. Rho is the density of liquid. Rho is what? Density of liquid. And what is G? It is nothing but acceleration due to gravity. It is what? Acceleration due to gravity. So pressure due to liquid column depends on 3 factors. One is what is the height. But over here this is not height, it is the depth of liquid from the free surface of liquid. What is free surface? The surface of liquid which is exposed to air. It is called free surface. Second, it depends on density of liquid, which liquid you are considering, whether it is water, whether it is oil, whether it is mercury. According to that, it affects the pressure. And G is what? Acceleration due to gravity. Now, if the value of G is not given, according to physics, you have to write as 9.8. But if your school teacher says you can take 9 point, instead of 9.8, you can take 10, then go for 10. In boards, they will give the value, they will specify the value of G, whether it is 9.8 or 10. So according to physics, if they are asking, then you should write 9.8. But if your school teacher says 10, you can write 10. That's it. So this is about the pressure. Now just the next part. Now, what is the total pressure? This is only pressure due to liquid column. Now, what is total pressure? For that, no, total pressure at a point is equal to, this is pressure due to liquid column plus your atmospheric pressure. What is atmospheric pressure? It is the pressure exerted by atmosphere on us. Now, what is that value of the atmospheric pressure? It is 1.013 into 10 raised to 5 Pascal, approximately 10 raised to 5, 1 lakh Pascal is the tremendous pressure exerted by Earth, by atmosphere on us. Then still, how can we survive? So we survive because our blood pressure is slightly higher than the atmospheric pressure. This part, this whatever we are discussing, that will be there in part B. So we'll discuss there only about this part. So over here, what is total pressure? I will write here PT, total pressure is equal to, I will write this atmospheric pressure first, that is P0 plus H rho G. So what is P0? It is atmospheric pressure. What is H rho G? It is the pressure due to what? Liquid column. So what is PT? That is the total pressure at a point, right? So there are two important terms in this part. One is what is pressure, and second is pressure due to liquid column. Now frequently they are asking factors on which pressure due to liquid column depends. It depends on three factors. One is what is the depth from the free surface. Second is what? It is the density of medium, and third will be acceleration due to gravity. Sometimes they can take the factors on which pressure depends. It depends on two factors. One is magnitude of force, and second will be the surface area. Now, what are the application of this part? What is the application of this pressure due to liquid column? If you observe dam, so the construction of dam is made something like this. This is the base of dam. So the base of dam is broad. Why it is made broad? This is your water, right? So as you go down from the free surface, what will happen? Pressure will increase. So at this bottom, pressure is what? Tremendous. So if I made this dam like this, if I make like this, like a wall, what will happen? So due to this tremendous pressure, this part will burst. So it will break your dam. To protect that, the base is made broad. Okay? Now the other part of this is application based question is something like this. You have, say, water bubble in a container. We'll go with this part. Say this is the container, right? This is water. See, there is an air bubble over here. Now it is observed that as this air bubble rises up, its size will increase and finally it will burst. So it is based on what principle? So when it is at depth, highest point, pressure is maximum. According to Boyle's law, this is there in your chemistry. This is according to Boyle's law. According to Boyle's law, pressure is inversely proportional to volume at constant temperature. So pressure is inversely proportional to volume. So over here, according to our pressure due to liquid column, as the depth increases, pressure will increase. Pressure is more, but volume is less. As it come up, what will happen? Pressure will little less, but volume will increase, and this same principle will be applicable. So this is the application based on this part. Now the student, that's it for this video. Next part we will do numericals on the same part. Thank you.